Hello again. Welcome to the third video of the Paleopathology module. This video is about skeletal trauma. You probably think right away of bone fractures, that is, a partial or complete break in a bone. This figure shows one way of categorizing the different causes and types of bone fractures. And in the online discussion forum, you will find a question asking if you've broken any of your bones, either as a child or an adult. But there are other types of traumatic injuries that we can sometimes see in the skeleton, including when a bone is permanently or at least very frequently dislocated or displaced, when nerve and/or blood supply is disrupted for a long period of time, causing the bone to atrophy, or even artificially induced changes to a bone's normal shape, such as caused by artificial cranial deformation, corsets, or foot binding. Now, we think of such practices as having occurred only in the past, but is that really true? Think about it. There are a lot of cultural practices undertaken today that have a significant effect on the shape of your skeleton. This is another topic for you to discuss on the online forum if you'd like. In past peoples, we often find evidence of trauma, most often via broken bones in various states of healing, and we will focus on bone fractures in the first part of this video. In the second part, there's a case study about cranial gunshot trauma. The type, location, state of healing, prevalence, and age and sex distribution of bone fractures provides osteoarchaeologists with evidence for a number of things. For example, fracture patterns can tell us about the types of activities a person was engaged in. It's easy to imagine that a rural crop farmer would be exposed to a different range of activities than a business person living in a city, so resulting in a different risk for different fractures and of different areas of the bone. You can also imagine that different activities might be engaged in, for example, by hunter-gatherers versus agriculturalists, men versus women, sailors versus people living inland. And finally, with fractures and other traumatic injuries, osteoarchaeologists can often detect episodes of violence in the past. A broken bone undergoes 4 stages of healing, depicted in this figure. This is important to know because it gives us an idea of the stage of healing and thus how long ago a break occurred. To briefly explain what you see in this figure, upon initial injury, torn arteries release blood into and around the fracture site, which soon clots. This is called a hematoma. During this time, the bone cells around and outside of the injury site die, and after 2 to 3 days, the blood clot is invaded by capillaries and fibroblasts, and then bone-forming cells. By 1 to 2 weeks later, these cells have deposited collagen and fibrocartilage, and this forms a soft callus. Soft because it's not yet mineralized. By as early as 3 weeks and as late as 3 months later, the soft callus will become mineralized, forming a hard callus, made first of immature woven bone and later of remodeled lamellar bone. The final stage is by far the longest, taking up to 7 years, and it consists of the gradual remodeling and realignment of the bone, which, if the fracture was set properly, can eventually lead to the disappearance of any evidence of the fracture. The amount of time this takes will vary based upon a number of factors, including the fracture type, bone area, age of the individual, so children heal much more quickly, if there was infection, the degree of immobilization, and one's nutrition. Now that you have a basic understanding of how bony fractures heal, you can watch a short optional video which shows you a few examples of bone fractures from our laboratory. In the second part of our video, we're going to look into a case study about a very specific type of trauma, that is, penetrating, high-velocity injuries to the skull caused by bullets. Most of you will now think of gunshot wounds made by high-caliber firearms, like in a modern forensic case. This case study, however, is a bit different. The setting is the Dutch city of Alkmaar, shown here, And the event occurred in 1573 during a siege of the city during the 80 Years' War between the Spanish and the Dutch. Rachel, welcome. Thank you for joining us today.
Thank you for having me.
So tell us about what you were excavating in 2010 and what led you to conclude that you had uncovered victims of the Siege of Alkmaar.
In 2010, we were excavating at the Paardenmarkt in Alkmaar. This used to be the site of the Franciscan friary with associated cemetery. On this site, we completely unexpectedly also found 2 mass graves containing 9 and 22 individuals. The dating of the graves, as well as the medieval bullets we found associated with it, led us to believe that we had uncovered victims of the Siege of Alkmaar in 1573. The demographic composition of these 2 mass graves was quite different. The smaller one, with 9 individuals, contained both men, women and children of all ages. And considering this, we thought that this might have been the civilian victims of the siege. The larger mass grave, of 22, only contained young male individuals. And this led us then to believe that these might have been the soldier victims of the siege.
Very interesting. So then tell us about the cranial trauma that you observed in the skeletons.
Yes, when we indeed brought the skeletons back to our lab, we quickly found that many of 4 of the individuals sustained cranial trauma caused by bullet wounds. This individual from the smaller mass grave shows a clear signs of cranial trauma caused by bullets. So here you see an entrance wound, and here you can see the exit wound. Since a cranium consists of an outer table and an inner table, the exit and entrance wounds can be quite easily distinguished. Here you can see the entrance wound, and on the inside you'll see internal beveling, which is caused by the bullet traveling at this direction inside of the skull. On this side, the exit wound, you will see the same process, but then on the outside of the skull. The bullet travels this direction through the skull and comes out here. And this is called external beveling as a result of the bullet traveling outward and flaking away little pieces of bone.
Very interesting. So from this larger mass grave, did the young adult males have other pathological lesions that might suggest they were indeed soldiers?
In addition to the sex and the age of the individuals, which is already quite indicative, we also found other pathological lesions which would be suggestive of them being soldiers. Many of the individuals sustained trauma in their spine as a result of degeneration of the discs. This you can actually see quite well on the bones. And this happens normally in older individuals, but here we also saw this in the adolescents and in the younger adults, which is quite uncommon, and is suggestive of them performing physically demanding tasks or carrying a heavy armor, for example. Additionally, we found antemortem trauma, more than you would normally find this in a cemetery. We found that several individuals had broken ribs which were completely healed over at the time of their death. In addition, there was one individual with healed sharp force trauma. Apparently, this individual was struck on its head with a blade, and this had completely healed at the time that he was actually shot as well and ended up in one of the mass graves. This, together with the age and the sex of the individuals, led us to believe that these were indeed the soldier victims of the Siege of Alkmaar.
Wow, what an amazing discovery. Rachel, thank you very much for joining us and taking the time to explain to us your research.
You're welcome.
There's a final component of this research that we will tell you about today. I'm pleased to introduce Professor Dr. Menno Hoogland. Professor Hoogland is Rachel Schatz's PhD supervisor, and he directed the forensic reconstruction research that was undertaken to better understand the ballistic, the gunshot trauma that was seen in these individuals. Professor Hoogland, could you please tell us about that research?
Yeah, sure. So, from the historical sources, we know that the weapon of the Spaniards was the arquebus. And that is an 18mm caliber weapon, shooting heavy bullets in the range of 35 to 40 grams. In the first place we were interested to replicate the trauma pattern Rachel has shown in the crania from Alkmaar. And in the second place, we were interested in verifying the distance between the shooters and the victims.
Interesting questions. And so what exactly did you do?
So we contacted the Netherlands Forensic Institute, and in the institute Rob Hermsen is the ballistic expert, and with Rob we made an experimental setting for this research. So he was shooting with a modern weapon, but charged with an old-fashioned round 35 grams bullet. And then the target was this sin bone replica skull, and we recorded the experiments with a high-speed camera.
Interesting. Okay, and so what was the outcome?
So we could indeed confirm that the weapon was the arquebus, and that the velocity of the bullet was pretty slow. It was only 100 meters per second. If you compare that with a modern weapon, that is in the range of 500 to 900 meters per second. So that is really, really slow. And such a weapon, as soon as the bullet has speed, then it will continue until it drops down by gravity. And we could confirm that indeed the distance was in the range of 30 to 80 meters. And if you compare that with details on a 16th century painting in the Alkmaar museum showing the siege of the city, then indeed you can see that the distance between the shooters and the soldiers on the city wall is about in the range of 50 meters.
And what did you see on the sin bone replica?
Yeah, what you can see here, that is the entrance wound. Here you see the same beveling as Rachel has shown on the cranium of Alkmaar, and the same pattern of fracture. However, the exit wound is different, and that is different because the replica skull is filled with ballistic gelatin, and the gelatin is behaving different than our brain tissue.
Very innovative and very informative research. Professor Hoagland, thank you very much for joining us today.
My pleasure.
In this video, you've learned about a subfield of paleopathology, skeletal trauma. Now you know the basics about how a fracture heals, and you've seen an interesting case study about gunshot trauma from a war that occurred over 400 years ago. Has this left you curious for more? Would you like to see how a lack of vitamin D, the sun vitamin, can affect your skeleton, and the ways that this can tell us about how people lived in the past? If so, stay tuned. Next, we will explore a disease called rickets.